Yep. Shoot.
So there's actually a few, but
Good. Don't worry.
with 13B.
There should be a few.
Actually, should I go in order?
If you told me there was only 5 or 2, I would say you didn't even do all of it.
No, I have 7.
Yeah, they're good. All right, 13.
B.
All right, wait, hold on. One step at a time. Let's see what we've got to do first. So show that if x equals tan theta and s equals sine 2 theta, then sx squared minus 2x plus s equals 0. You were able to get that out?
Yeah.
Okay. Hence or otherwise show that tan 15 degrees is equal to 2 minus root 3. Give me a second just to think about it all. I solve for x. Okay. If you see the word hence and you see obviously this, what do you think you're going to do to it?
Use it.
How? What specifically?
Would you somehow sub it in somewhere?
Okay, nope, it's not going to be a sub. It will be, but it's not necessarily like that. I want a different word. Anyone else? Obviously, what did you guys try to do? Somebody else. Hence, it says this. Come on, who cares if it's wrong? Just say, what would you guys think?
Could you make them equal each other?
Could you make them? What do you mean by them?
Like 10, 15 minus 2 plus root 3 equals 0.
10, 15 minus 2 plus root 3 equals 0. I see what you're saying. No. I see what you're saying, but no, don't need to do that. That's very creative. I like it. Different questions will require that thinking. Not for this one. I'm making it even simpler. It's just this. It just says hence. Obviously, you're going to use this. I'm just thinking, what are you going to do with this? What do you guys think? Come on. It's got to be like screaming at you. Look at it.
Make 10 a subject.
Make 10 a subject. No, I feel like you're saying the right thing. It's not what I want to hear. Just with this. Maybe. What do you mean by that? There's a word that you guys would say usually. You wouldn't say make X a subject. It's an S word. All right, we'll go start again. Look at this. It says equals to 0. Come on, you're getting close, Matty. Maybe keep saying it. Keep saying stuff.
You'll just solve it.
Solve. How come you guys aren't seeing the solve? X squared, X, and it's a constant. Right? See? Trinomial. Can you see it now? That's a trinomial.
Yeah.
Right? It's got nothing to do with this question. I just want to make sure you guys understand when it's saying hence and how to relate that hence to the previous question. It's trying to pretty much say hence to use it, which means in this case, if I've got to use it, you're going to solve it. Obviously, when you solve it, it's what Mariette was saying, which is you're going to eventually get x as a subject, which is 10, and then you'll see stuff. You guys will see. But the key thing there, I think, was solve. So let's see. Let's play with that. Sx squared minus 2x plus s equals 0. Solve. So x equals minus b plus minus square root b squared minus 4 times a times c on to a. Is that fair enough? Aya, what do you reckon? Sounds good?
Yep.
Looks weird, but though, doesn't it?
Yeah.
That's when you have x equals what?
Tan theta.
And s equals?
Sine 2 theta.
And then obviously what does theta equal to?
15.
Because you want tan theta, right? 15. So then s is equal to sine 30 degrees, which you know is a good number. You like 30. So plug sine 30 in your calculator, gives you a half. So now you're going to fix this one up. X is obviously tan 15 now. I think we all agree with that. X is tan 15. And then, which means here, this equals 2 plus minus square root 4 minus 4 times, yeah, I think we get it, 4 minus 4 half squared on 2 times a half, which is 1. 4 a quarter, that becomes 1. 4 minus 1 is 3. That gives me 2 plus minus root 3. Still with me? And then you're just going to write 10, 15 degrees equals 10, 15 equals 0.267, let's just say 9, blah, blah, blah. 2 plus root 3 equals 2 minus root 3 equals, and then 2 minus root 3 will be 0.2679. So therefore these two are the same. Therefore 10, 15 equals 2 minus root 3. Do you understand that?
Are you talking to me?
Yeah.
Oh, yeah. That doesn't.
100%?
Yeah, 100%.
100% done. So you can see I didn't care about the rest because I feel like the rest we can get. I emphasize this for a reason because I know that's the problem.
If you didn't see the relationship between that and hence,
Yeah.
but on that answer, could you?
Yes. Yes, you could have actually. So now you want to do it the otherwise? All right. Can someone remind us how we did this as otherwise? I think Ben might know.
Yeah, that's his T formula, right?
You could have done, there's two. There's actually two. So there's two otherwise methods. So I'll give you that one. You could have used T formula where theta is equal to 30 degrees. So therefore you'll eventually find 15. Aya, do you get that?
Yeah.
But do you know how to use T formula? So then, you use whatever. Sine theta equals 2t on
1 plus t squared.
and then eventually you're solving for t because that's t is 10, 15. But at least you know theta is 30 degrees.
Yep.
And then sine 30 is half, and then you just go and solve for t. Make sense? But you'll still have the same problem, by the way. You're going to still get plus minus, and then you have to do this little trick here. The only way you can work them out is by subbing it as a decimal. All right, and someone else want to tell me a different method? Well, even Ben, doesn't matter. What would be a second method? Second method, 10, 15. Think of it, very special number, 15 degrees. It's a way of me getting 15 degrees using extension 1.
That's like your compound formula.
That's the one. 10, say it.
Yeah, the 10 ones always get me. Is it 1? Wait, no. Oh, God. Okay. I don't know my 10s.
No, wait, hold on. You said
Oh, wait.
compound.
10A minus B. Yeah.
Yeah, so what?
Oh, that's just like
45?
45 minus 30.
Or even, you could have, I think you were going to say 60. 60 take away 45. That would work. Whatever.
Yeah.
Yep, and then you could have just done 10, 60. That would have been probably be the fastest way. Who's bothered doing that as hence? Actually, when you guys see all three versions, obviously the fastest way would be this guy. 10, 45 minus 10, 30 on 1 plus 10, 45, 10, 30. I think all you needed to do was rationalize the denominator. Otherwise, it's done. 1 minus root 3 on 1 plus root 3. Is it? Is 10, 30 root 3? No, it's 1 on root 3. Okay, maybe a little bit harder with the math. But it would have still worked out. So, there it is, Aya. There's 3 methods.
All good.
And this one specifically is in our booklet. So that method, if you want to see it, it's in our Trig booklet. Even the T formula is actually. Good. Anybody? Doesn't have to do, or any other questions?
I got stuck on 3.
Question 3. Yep.
Like I've got a long list as well. So
Yeah, good. Don't worry. Just go. Let's just do them. Who cares? All right. Domain and range. Look, I'll tell you me. All right. For my trial, HSC, the first exam I did, I got about 20, I don't know, 25%. So it was horrible. Second one I did, I probably got about 27%. So you're meant to have a lot of questions. Do you understand? Like there's a lot of content. And you're not only talking about, like by the time it comes to your trials, you're talking about advanced and extension 1 for 2 years, or extension 1 and extension 2. Extension 2 is only 1 year, but extension 1 for 2 years. So there's a lot. Anyways, so you're meant to have a lot of questions your first time. You don't want to have this many questions by the time it comes to your prelims. That's our aim. All right, inverse cos of x. Does anyone remember the what? Okay, would anyone be able to teach this to us? What would I say? I guess if you guys know what I would say for this, then you know you're on the right track of being able to find domain and range. Who thinks they know what I would say of how I would teach this now?
You'd first write down the original domain and range. Wait,
Yes.
which is that? Yeah.
Yeah, and
I
even,
mean,
even before that, how would I know the domain and range?
oh, you'd flip the normal cos.
You're getting very technical.
You get the domain and range of cos x, and then you'd.
You're right. You're right. I'm saying, what if I had just memorized the original graph
Oh.
of inverse cos of x? I would have found my domain and range from that. That's probably what I would have said first.
Oh, okay.
But it's good. You're getting close. So it is essentially finding domain and range, but I don't memorize domain and range for each one. What I do is I memorize the graph of each one. So this would be 1, minus 1, and if I'm not wrong, this should be 0, pi, and 2 pi. Is that right, Ben?
Isn't it pi on 2
Pi on
in the
2,
middle?
sorry, what am I drawing?
So. I think, yeah.
That should be it. I don't know why I drew 2 pi. Pi on 2, pi, negative 1, and 1. So if you memorize your original, so Mayette, for example, have you memorized your original?
no.
Then obviously this question will be impossible. Cool? So you just found a little weakness. What you're going to do is memorize, I guess, inverse sine, inverse cos, inverse tan. Or if you don't like to memorize, draw this up right now, put it on your wall. Leave it there, like I had said to you guys before. Because I know you guys are not going to memorize this, which is why I always say about the whole wall thing. Put it on your wall. And believe me, you'll memorize it. Domain, negative 1, less than or equal to x, less than or equal to 1. Range, 0, less than or equal to y, less than or equal to pi. So it's easier to memorize this graph than it is to memorize domain and range, in my opinion, but whatever works for you at the end of the day. All right. Then what we said was if this is monic, like it is right now, then this just stays the same. It's just going to be this. Our range is not going to change. If it was not monic, so if it was 3 in here, or if the amplitude was 3 here, then what we do, we have to make it monic. So we get rid of the 3. This will be a division of 3. This will be a division of 3, and then you'll multiply by 3. Any questions there? No? Okay, and then if it was whatever for your x's, you just change the x to that thing. So it will look like this, minus 1, less than or equal to 1 minus x, less than or equal to 1. That would be your new domain. And then you're obviously going to solve for x. So subtract 1, minus 2, less than or equal to negative x, less than or equal to 0. Divide everything by negative 1. You'll get 2 greater than or equal to x, greater than or equal to 0, which means it's 0, less than or equal to x, less than or equal to 2. Mariette, question? Or anyone? Any questions? Mariette? No? All good?
No, I got it.
You got it? Kind of remember us talking about it like that? I said if it was monic, divide it, because. Do you remember the idea of how we did our domain ranges though?
Yeah.
Yeah, cool. So the only part you've got is going to take you about 5 or 10 minutes. Just memorize your graphs for each. There's only 3 of them. Inverse sine, inverse cos, inverse tan. And then just remember what I just said there. Has to be monic. And this one, it doesn't matter what it is. You just replace it. And you should be good to go. Cool. Go. Next. Next question.
Question 6. I got B, but I don't know if it's right.
Fair enough. Shouldn't have been yet, if I'm not wrong. This should be part of the Year 12 course. Now, so it doesn't matter though. Yes, this is part of Year 12. Have you guys done y dash and y double dash? Just making sure. No, didn't think so. So this is the second derivative. Nope, not interested. Not in it right now. So all good. But do you really want to know the answer anyways, or not really, right? Because if it's not important, don't worry, forget it. Next.
What was the answer for?
You want to know the answer?
Yeah.
All right, hold on. Hold on. A particle has x being greater than 0. So that means it only exists for this bit here. X is greater than 0. The x dot means y dash. We just don't write x dash because it'll confuse everybody. So for x's, we put dots. So y dash is less than 0, which means that it is decreasing. X double dot, for those who remember, I think just on Monday, we literally talked about this. Y double dash is less than 0. Y double dash less than 0 means that it is a less than 0. Means it is a maximum. So y double dash less than 0 means the max. So that means you've got something that's here. You've got it looking like a maximum parabola, let's say, and it is decreasing. Where is this thing decreasing? Is it decreasing from the left side or is it decreasing from the right side? It's obviously flat there. It's not increasing or decreasing there. Where is it decreasing? Well, that's all positive gradients. Positive gradients, so it's increasing. These are negative gradients, right? Slope to the left. So it's decreasing here. So the answer is the particle is moving away from the origin, as you can see now, the particle is moving away at an increasing rate. So that's a tricky one. The particle is moving away from the origin at an increasing rate. Now the reason why it's increasing, don't worry, you guys don't need to worry about this. It's deep. You had the increasing rate bit right, but that's it. It's moving away. Doesn't matter. All right, next one.
Question 10.
Question 10.
Is that what we just did last week?
That is exactly what we just did last week. You're right. Could you do it? What happened?
No, like it's a 5 choose 0 plus 5 choose 1 thing. But for the x bit, I didn't know if I was supposed to put the whole minus 3x into the... Yeah, start with that one first.
Wait. Let's start with... You said you started with that one first. That's fine.
Because I didn't know for the...
How annoying, right? Bloody, you guys know how long this takes, and it's a multiple choice, which is what I was trying to teach you guys. Look, as you do these exams, the whole point of them is not just to do exams, it's also to understand a strategy for your exam.
Yeah.
And the strategy you got to think about is, wow, am I going to really waste all this time, which is usually worth 3 marks, for 1 mark? Hey, I could just take a guess. If I'm running out of time, I actually have other things I've got to work out. Right? I've got to do all this stuff, which I might not be able to even guess if I don't actually write something down. So it's a guaranteed 0. Whereas that one, at least you got a 25% chance. You guys got to really understand that. But obviously, we've got infinite time right now, so different situation. 5. Choose k. A. 5 minus k, and then minus 3x to the power of k. Is that right?
So it's not the expanding one.
No.
That's what I did.
That expanding one really, other than like a 1 mark, I don't know, a simple question, it's not really what we test in extension 1. That's just to get you warmed up. Really, I don't think I've ever seen to expand as a question.
Okay.
It's usually to find the coefficients or to find the term or whatever it is.
Yeah. What
is the coefficient? All right, doesn't matter. We'll continue it. And then this one would be 1. I mean, it's not complicated. This is just 1 plus 2x, right? It's power of 1. I'm not going to complicate it. That's just this. Leave it as it is. Don't overkill it. Now you guys got to think about, how do you get x cubed from this multiplied by this? Well, you'll get x cubed by 1 multiplied by this and this multiplied by this. So 1 multiplied by this. 1 to the power of anything is 1, so ignore it. And then that gives me negative 3 to the power of k, and then x to the power of k. Do you understand what I'm doing there, Aya? When I'm saying 1 multiplied by this?
Yeah, I remember from last week.
Plus 2 multiplied by this. 2 multiplied by 5ck. Again, 1. And then this becomes negative 3 to the power of k. And that becomes x to the power of k multiplied by x. Do you understand that? Does anyone not get what we're doing at all? Like, guys, oh, I don't really understand what's happening. Seriously. Because you guys can see, you can't run away from it. It's going to be in your exams. Wait, maybe I'll just give you a simple question just to wrap your head around it. If I gave you this, imagine I told you, how do you get x's? Would you guys agree that it would be these two, and then you would say these two? Because the other ones will give me constant or x squared. I'm using that logic. I'm thinking, okay, how do I get x cubed? Well, x cubed could be 1 multiplied by this, which I'll get in a second. Or it could be this one multiplied by this as well, but it's got to still be an x cubed, which I'll get to in a second. So we understand the logic of it. If I did this first one, I need to get x cubed. What would you say k equals to then?
3.
3. So this would be 5, choose 3, minus 3 to the power of 3. This one, if I needed x cubed, don't forget this is k plus 1. Hold on. Hold on, I know it's not you guys. Come on. Can we hear me well, or is it still better now? Are we back?
It like cuts in and out.
What about right now?
Yeah, it's good.
Better now? Okay.
Yep.
Yeah, that's, again, if I get a call, that's what happens, unfortunately. Okay, x cubed. But I know to stop now. X cubed. What would k equal to in this case then?
2.
2. Because that would be 2 plus 1 more, you'll get 3. Aya, does the logic of it now make sense?
Yeah, I remember from last week. I remember. And then
And then literally just looking for your answer now. So what? That's minus 5 choose 3, 3 cubed plus 2, 5 choose 2, and that's what, positive 3 squared, if they have that answer. Whoa, which one is this? Minus 5 choose 3, 3 cubed, 2, 5 choose 2, 3 squared. The answer is C. All right, any questions from anyone? Cool. All right, next question.
14.
Next week it'll get easier. The week after it'll get even easier. The week after that it'll get even easier. So don't worry. 14. 14. 14. Okay. All of it? Or
Yep.
okay. All right. Again, like I said to you guys, I would have memorized what would have happened to my original, which is that. I've memorized that, so I know intercepts are asymptotes, and then happy, sad. So I'm going to pretty much replicate that. I'm going to do it all on the same graph, if that's okay. So we'll do the first one. We'll do 1 over f of x. Intercepts, asymptote, asymptote, asymptote. Down here will look like this. 1 over small is very large. 1 over large is very small. Down here will also look like this. Okay, in the middle somewhere. All right, 1 over small, very large. 1 over small, very large. Right? Maria, you agree with that? 1 over small, very large. 1 over small, very large. 1 over 2, half. That is a lot higher. Like, look at, that's at 3, let's say. So that should be 1 over 3. It should just come a bit lower and then go up. Do you understand? Do you understand that? Yes? Yeah. And then same here. 1 over small, 1 over small, and then whatever, 1 over, like let's say, look, this looks like a third. 1 over third should be 3. Whatever, somewhere up here. Who cares? So that's a bit higher, because these are all small numbers. So 1 over any number that's smaller than 1 will all be large. They're never going to come down here. These are smaller than 1. So that's that. Anyone actually able to get that out correctly? No? No one got it out? Damn.
I got it.
Oh, you got it. Well done. Well done, Nada. Good job. Something like that. Have you memorized your basic ones? Nada, do you have them on your wall?
Yeah, we did them like the whole time.
Yeah, beautiful. There you go. All right. Okay. 2 marks. Next one. Y squared equals f of x. Can I rub this out? Not yet? Is that fine?
Yeah.
Y squared equal. I'm just trying to draw it on this so you guys can actually see what it's doing to the original. All right, y squared. Again, you've got your original one, and you know what to do with your original. Y squared. What does y squared do? Let me remember this myself. Okay, it takes all the positive ones and it changes their concavity to like this, right? So the idea is it becomes more parabolic in nature, but it's about where it's positive, reflect down. So pretty much ignore this, ignore this. That's the first thing. Then you think about it like, well, you're going to square root, aren't you? Because it's plus minus root f of x. So you're square rooting 3. Square root of 3 is somewhere here, 1.73. And then square root of 2 will be 1.4, so somewhere here. It'll specifically cut through there. And then square root of all these numbers will be even smaller. So this will look something like this. Oops. So like think of the square root of this number, it'll be smaller. Square root of this number will be smaller. Ugh, I can't get it out. So I'm not going to stop. There you go. That should have obviously not been on top. That should have been more lower if you're going to draw on the graph. But if you didn't have the graph, which they don't here, no one would have known otherwise. And then down here, the answer should be even smaller. If I'm going to do it like that. So essentially, if you had to draw it on your paper, it would have looked something like this. Nope, it wouldn't have looked like that. It would look like this. Oh, I can't get this out. There we go. And then it would have had this one. Joining like that. And then the most important bit is this number here being at root 2. This would have been a little bit higher and then comes down because root 3 is higher. Oh well, I think we get it. It's very hard for me to draw with this tablet. Not yet? What do you reckon? Don't get it or we get it?
I get it.
All right, next. So then what was hard about this? Did you just forget your original graphs? Is that the problem? Like you forgot the transformations, or you thought...
I get mixed up with my transformations.
Yeah, yeah. It's the same thing. Again, I would tell you, put it on the wall. Believe me. Don't underestimate that wall of yours. All right, go. Next question.
C.
15C. Boom. All right, the diagram shows the graph y equals 2 on 1 plus x squared. Yep. Consider this function for x being greater than or equal to 0. The function f of x has an inverse. Okay, and consider it for greater than 0. So let's just maybe get rid of that for a second. Do not prove this. Okay, state the domain and range of inverse of x. Oh, okay, fair enough. Well, we already know the domain is for the original. We always do it for the original. So domain is x is greater than or equal to 0. And can someone tell me what the range is of the original one right here? What's your range?
Between 0 and 2.
0, including 0 or not including 0?
Including.
Including? Nah, no way. It's an asymptote. Right, it's approaching, does not equal to 0. Does not equal to 0. So be careful. Not including 0, but including 2. So your domain, where are we? Your domain would be 0 less than x less than or equal to 2, and your range would be y is greater than or equal to 0. So you just swap your x for your y and your y for your x, and that's a pretty straightforward 2 marks. Any questions? Sketch the graph of inverse x in the space below. Okay, it's got to be between 0 and 2, and y is greater than 0, so let me just picture it. I'm going to flip this, that's going to go it's going to look like this. Oh, there it is. Okay, so let me draw it up. Can everyone see the reason why I drew that? Can you guys see how it's symmetrical about y equals to x? Hopefully, because that was the idea of the inverse. If it's at y equals 2, we know it's going to be at x equals 2. And then it looks pretty much what I drew there. So there it is. So it can't reach 0, but it approaches 0. So that's technically an asymptote. And then here, you see I've got my pen, unfortunately, you see it's gone back. You guys got to know it's not going back. It's like this. But I can't do that there. All right. Now I'm looking like you, Stefan. Brings back some memories, doesn't it? There you go. All right. It's going to look like that. There it is. It's between 0 and 2, and y is greater than or equal to 0. But I think you guys can probably see even better when I drew it up here. So it's got to be exactly symmetrical to that. All right. Any questions there? Okay. Next.
16.
Oh, C? Should we do, or that one's easy? Or
We forgot C.
I asked you to do C.
no, you can't do C?
Nope.
What? Do you know what to do with C?
Not really.
Oh, okay. Anyone tell us a way to do it?
You just swap the x and y,
You just
and then
swap
you
the
solve
x
for
and
y.
Yeah, that's it. So swap the x for the y. 1 plus y squared equals 1 on x. Take away 1. And then square root. I'm guessing it's worth 3 marks because most students would leave it at that. But you just found your range. Don't forget, you wrote y is greater than or equal to 0. Therefore, y equals root 1 on x minus 1. So just be careful. You got to question why it's worth 3 marks if it's just a simple substitution and solving. And that's the giveaway. Okay, Raya.
16.
16. Yep. So it looks a lot of inverse. You guys have forgotten it because we did it a while ago. I get it. But hopefully this brings back some good memories, and then next week will be better. Prove the following trig results. Anyone help us out with what we did with this one? Still nothing? What if I say that?
You use the compound formula, I think. Oh, not the formula, like you'd use the...
I don't think we need to. I don't think
okay.
we need
Oh.
to. I don't think we need to, but I think you got the right idea, but I don't think we need to. Does anyone, do you remember what we said? Let something be something?
Is it? Oh, it's probably wrong. Is it let alpha? Oh, okay.
You got to not do what you just did there. Don't say it's probably wrong. Do it and then see if it's wrong. Instead of it's probably wrong. Go. Let alpha equal.
Line.
Come on, sound more confident than that.
I'm not.
Inverse sine x. And then we're going. Yeah, then we're going to sine it. Okay, and then what about this one? What would you let this one be?
Beta.
Beta equals inverse cos x, which means cos beta equals to x as well. Then from there I said go ahead and draw a triangle. There's your alpha. Opposite over hypotenuse. Hypotenuse is 1. If you draw the same triangle for this guy, if you do beta there, and that's going to be adjacent over hypotenuse, the logic is if that's alpha and that's opposite, well, that's the same as me labeling beta there. Because beta is still going to have adjacent as x over 1. Can you guys see that? So technically, you're meant to avoid drawing this. But I just thought I'll draw it up just so you guys can see what happens. And then what are you going to conclude from that? Therefore, alpha plus beta equals to? 90 degrees, right? Because you know those two have to add up to 90 angle sum of a triangle. You're done. Well, obviously, just finish it off properly. Inverse sine x plus inverse cos x equals to pi on 2. All right, good. Any questions? And I got to make one more quick point. I think you guys are realizing something in extension 1. Compared to advanced, when you do your advanced paper, are you realizing in extension 1, pretty much everything you get taught, like we got taught this, right? We did exactly this question. Can you see how it's in the exam? That's a good thing about extension 1. It's why I personally preferred it. It's why Azra's not here right now. It's why Azra's doing better in extension 1 than she's in advanced. There's less topics, but whatever you I guess you learn is tested. Whereas in advanced, you guys got all of this. There's a lot to know, and you're only going to get tested this bit. So as you study, you'll realize, wow, like the next exam, you'll see you're gonna pretty much get this question again. You're gonna get a reciprocal question for those graphs. You're gonna get an inverse function for whatever. I just thought I'd make that point. As you guys revise this, you'll realize, wow, this is actually a lot easier than advanced. Anyways, until you get a question like this, then you forget about what Sam just said. No, I'm kidding. All right, what are we going to do? I think for this one we've got to use that formula. So I've got to go here and find the formula. It's the only one I said to you guys I will allow you to look at your formula sheet, because everything else is going to be memorized. But this one here, you probably don't need to memorize it. All right, we don't need to memorize that. So let's see how to use this. I'm going to take a snapshot of that. Bring it here. Okay. You guys have a look, and I'll look as well until we find what we think we're going to use. Now, what is it? Prove or solve? Prove. Okay, prove. Prove this is equal to this. Okay, what are you saying? So, equals to sines. Okay. Sine cos. I guess so. All right. Can someone tell me out of the four, which one they think, or which one do you think I probably won't use? Maybe we should say that. Which one do you think I won't use? 1, 2, 3, and 4.
1.
Which one?
The first one.
Yeah, and what's your logic there?
Because it's all cos.
I agree. All causes. I don't think that's going to be helpful just yet. And then, while you're there, maybe what do you reckon? Number 2?
The second one we won't use.
Yeah, as well, right? It's got causes on the right-hand side. I don't want that. So, and then just so you guys know, actually it doesn't matter which one you choose. They're so similar, these all four of them, in fact, that it doesn't matter. But it's obviously smarter to not choose that one and that one. And then out of these two, it doesn't matter. It doesn't. Really, it doesn't. But I'm going to pick the plus only because this says plus. So I'm going to choose this. And let's see how this works. What do we have? We've got sine A, so sine 4, let's call this 4 theta instead of omega, cos 2 theta. Let's do that. So sine 4 theta cos 2 theta. Sine 4 theta cos 2 theta. So this is A, this is B. That becomes half sine A plus B. 4 theta plus 2 theta, 6 theta. Plus sine 4 take away 2, 2 theta. Okay, I'll stop there. I'm not entirely happy because obviously you guys can see this says 7 theta and 5 theta and whatever, but oh well, it is what it is. Anyone have any questions at this stage? Nope. Okay. Can you tell me what my next step would be, Maria? Now that you know that, what would be your next step? So you got pretty much this and this out of the way.
Expand the brackets.
You mean like bring this in? Half sine 6 theta and half sine 2 theta? Sure. Yeah. And then keep going. What else?
Turn cos into sine.
Turn cos. This cos you mean?
Cos 2 theta.
Wait. Hold on. We've just said this is now this. But,
yeah.
But that's not the left-hand side. I've still got all of this, and I've still got a 4. So what are you going to do to this line? Technically. Don't forget what you're trying to prove, right? You weren't trying to prove this. Were you trying to prove sine 4 theta cos 2 theta?
No.
No. Where's your cos theta? Well, what are you going to do now? You're going to multiply everything by 4 cos theta. I hope. So let's multiply everything by 4 cos theta. Multiply by... I'm sure you understand my logic there now, right? You weren't done here. Look, it's not done. But now you've got the result you wanted. And on the right-hand side, you've got 4 times half, which is 2. 2 times sine 6 cos theta. Sine 6 theta cos theta plus sine 2 theta cos theta. You agree with that?
Yep.
100%, right? Be honest. 100%. Can you do that line for me?
Yeah.
Yeah, because first, it's just knowing, and just so you guys know, right? Everyone goes, okay, Sam, but how do you know to do this one and this one? It doesn't matter. I just said that to you guys. It doesn't matter. It'll all work out. Believe me. I know these formulas. It doesn't matter. You could have done cos and cos. So you could have done the one you said not to do. It's just not the one I would have chosen, but you would have worked. Because then when you do sine with the causes, it's still going to get you sines. You could have done this one with the... It doesn't matter. That's it. I just want to make sure you guys understand. It doesn't matter. It's more about the way I approached it, which is I took 2 at a time. You couldn't do all 3. That doesn't make any sense. So 2 at a time, get your result, then multiply it by what's missing. Then you'll get another result. Of course, sine 6 theta, cos theta. And then if you want to think of it, there's your multiplied by 2, just to make it easier. We don't have to draw the half. That becomes, again, A plus B. That becomes 7 theta plus sine 5 theta. I'm sure we can all see the answer by now. Sine 2 plus 1 is 3, plus 2 minus 1 is done. What do we reckon? Can we do that? Maria, you reckon you can execute that now? If you had it again?
Yep.
Probably. Yeah, that's good. Okay, yeah. Half, and then multiply it again. It occurs again, and then bang. Really, I wrote the answer now that I realize. I didn't even do much after if I knew when you're going to multiply. Okay. All right, good. Next.
17.
17. Let's do it. The radioactive isotope fermium-253 has a half-life of 3 days. Initially, there is a sphere with a volume of 12. The volume, see how I'm trying to ignore the stuff that you don't need? The volume satisfies this equation, dV on dt equals negative kV, which we know must be the case for exponential growth and decay questions that we've done. That must be the case. And then it always say, show that V where A is a constant. The way you're going to do that is bad question. It should have been show that this is an equation that satisfies. Yeah, the volume satisfies this equation. Show that V equals. But that's okay. So it should have been worded a little bit better. It's not show that this, but it doesn't matter. We're going to differentiate dV on dt. We bring the. Hopefully, we remember how to differentiate exponentials. We get negative k, a e negative kt, and then again a e negative kt, a e negative kt. That just becomes v equals negative k v. Does that ring a bell? Yes?
Yeah. This is the rate change, right?
Yeah, it's part of rates of change, yeah. And then we did the this is specifically more the exponential bit. So this is meant to be the easier one because it's always going to be the same equation. It's never going to change. The rate ones where we actually use sphere and stuff like that, those were the harder ones, which I think this one's going to bring in soon from the looks of it. All right, well, let's keep going. Find A. Now we know the formula. Who can remember how to find A? What's our method to finding A?
Subbing in what we have.
Yes, can you tell me what you mean by that?
So instead of V, we put in 12.
Correct, and instead of T, we put in? Say it again?
3 or 6, because it says like
No,
Zero.
0. Initially. Initially means always time equals 0. And A is always initial, just so we remember that. So V is 12, which means e to the 0 is 1, so therefore A equals to 12. Always A must be your initial amount, initial population, initial volume, initial whatever it is. Cool. Done. So we have a new equation, V equals 12E negative KT. Given that the volume of the sphere will halve in 3 days, that's the idea of half-life. So it's literally going to become half of its life, half of its initial value, I should say. So that means V is equal to 6 when T is equal to 3. So you guys just want to maybe remember that. Half-life means half of initial. Oh, initial. Okay, half of the life. So whatever it started, it got to half of its life is the idea. So half of initial. Okay, but anyways, they broke it down even more. Given that the volume of the sphere will halve in 3 days, find K. So when V is equal to 6, T equals to 3. When V is equal to 6, T is equal to 3. 6 on 12 is equal to a half. Log both sides. And then divide by negative 3. Whatever that gives you. Any questions? Cool. All right, and then last one. At what rate is the diameter changing initially? Okay, can someone tell me what that is even asking to find?
dv on dr.
dv on dr, incorrect.
Oh,
You're saying, just so you know, you're saying the change in volume with respect to the radius changing.
wait. Okay, yeah, never mind.
You're close. At what rate is the diameter changing initially? Okay, rate definitely means differentiation, and it is dt on the bottom, Ben, just so you remember, for when you're seeing a rate. So dt is going to be on the bottom, and then obviously, if we're going to do diameter, we're going to call it dx, just so we don't get confused with radius. So dx on dt would be the same as dx on something and then something on dt. And I think it's fair to say that that's going to be volume and volume. dv on dt, we already know dv on dt is negative kv. So let's go here. dv on dt is equal to negative kv. And it's saying initially, which we can work out in a second, and we already have k, so we can work this out. This is not a problem. We need dx on dv. Can anyone tell me what I'm meant to use to find a relationship between volume and diameter of what? What was it for? Volume, diameter of what?
The sphere,
Okay. So
right?
what do you know? Volume equals
4 on 3 pi r cubed.
4 on 3 pi r cubed. But we don't want r. So what are you guys going to do?
X on 2.
Yes.
Wait.
Yes,
Yeah.
yes. Don't worry. I know. As long as you use brackets.
Yeah.
There we go. See the work there? Radius is diameter on 2. Very good. And then 4 on 3 pi x cubed on 8. And then we're going to differentiate that. Bring the 3 down. 3 times 3 cancels out. You're left with 4 pi x squared on 8, which is actually pi x squared on 2. And of course, we want a dx on dv. Dx on dv is 2 on pi x squared. 2 on pi x squared times negative kv. Okay, I'll pause there for a second. Have I confused anybody? Anyone not sure what I've done at any stage?
Why did it become x squared at the end?
How did it become x squared? Oh, differentiating. We're going to bring the 3 down, and then you're going to take away 1 from the power.
Okay.
Is that what you mean? Right there?
Yeah.
Yep. So bring the 3 down. 3 times 4 over 3 becomes just 4 pi, and then x to the power of 2, because you take away 1 on 8. You're differentiating v with respect to x. And then 4 on 8 becomes 1 on 2 pi x squared. Okay. And then we flip because it's dx on dv, not dv on dx. So you flip it. All right. Finishing touches. K, we have. V, initially we have. So let me write K equals C, whatever you found in C. V, what's the volume initially? I think it said 12. 12. What's the diameter initially? How do we find that? What is x equal to? That's weird. Any ideas? What is x equal to? Stefan, what do you reckon? What is the diameter equal to initially? How do you work it out? You already know what the volume is. Volume is 12. So you're going to sub it in here, solve for radius, and then eventually times it by 2. So I'll do that on the side. When v equals to 12, you guys get 12 equals 4 over 3. So 12 times 3 divided by 4 divided by pi, cube root, answer, times 2. X should equal to 2.84 whatever. Not an exact, obviously. And then plug it all in and you'll get the answer you were looking for, which I'm not going to plug in because I think that's fairly straightforward. All right. There you go. Okay. Any questions? All right. Next, then. Next one. Any other questions? Question? Nope.
18b.
18b. Can you tell me your answer for A?
I don't know if I did it right, but I got 0.2.
Just 0.2?
Yeah.
There are 10 balls labeled with the numbers 1 to 10. Kelsey randomly chooses 6 of them. What is the probability that at least 2 of the numbers Kelsey chose are even? All right, how do we do this? Let's work this out. There are 10 balls. 1, 2, 3, 4, 5, 6, 7, 8, 9. Kelsey randomly chooses 6 of them. What is the probability that at least 2 of the balls, at least 2 of the numbers Kelsey chose are even? At least 2. So 1, 2, 3, 4, 5, 6. At least 2. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. All right. So at least 2 of the numbers. So we've got to go. All right, how did you, I guess, how did you think of it?
1 minus probability of no even chosen.
No, because if you do no even chosen, what about you? Then you're going to get 1 even chosen, which you don't want. You want at least 2 even chosen. So if you're going to do 1 minus, you'll do 1 minus no minus 1 even. Do you get that?
Yeah.
Because you want at least 2. So be careful with that. You could have done that, or you could have done probability of 2 even, 1, 2, 3, 4, 5. Yeah, you could have done 2 even, 3 even, 4 even, and 5 even. Then you guys just got to evaluate which one's faster. Of course, this one would be a lot faster than this one here. So that is the strategy we're going to take. Okay. 1 minus the probability. Okay, so let's work this out. What's the probability of getting no even numbers? That means each one of these must be odd. So 1, 2, 3, 4, 5. There's 5 odds. Hold on, but it won't work with 6 numbers. So no evens, you can't do it that way. You can't do it.
Would it be with replacement or without?
Oh, okay. Hold on. Good point.
Cause if,
Yep.
yeah.
Good point. What is the probability that at least two of the numbers Kelsey chose are even? She randomly chooses 6 of them. Of them. I'm guessing the way. It randomly chooses 6 of them. If you're going to choose 6 of them, that means you're probably not replacing. So you're not going to be able to get. You're not going to get a case where there is no evens.
Yeah. There's at least going to be one.
So there'll be 1 minus a probability of 1 even. That's it. So that means all odd, 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 and 1 even. So all odd would be 5 factorial, 5, 4, 3, 2, 1, times one of the evens. So one of the evens would be times 5 or 6. 1, 1, 2, 3, 4, 5 times 5. Do you understand that? Do we all get that? Do we get my logic there? Probability of 1 even. 5 factorial. So 5, 4, 3, 2, 1. And then 1 even. How many evens do I have left that I can pick from that can go in the last position? 5. Does that make sense? But that's when order matters. Right? You guys still with me, or what's happening? I don't know. You guys confused? Maybe I'm doing it wrong.
So how else do we think about it? That's what I'm
Well,
stuck.
because so now I'm here now. 5 factorial times 5, but that's obviously when order matters.
Mhm.
Now, order doesn't really matter. So what I'm also going to do is, if order doesn't matter now. Order doesn't matter. I can pick. I've got. Order doesn't matter. I've got 10 numbers. I'm trying to choose 5. Order doesn't matter. Order doesn't matter. Order doesn't matter. Let 10 choose 5. Times 5. I'm going to place them there. Odd, 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 odd. What if I thought of it like that? Right, same thing. Odd, 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 odd. I've got 5 choose 1, which is still 5, times, these can be rearranged in 1, 2, 3, 4, 5, 6 factorial. I think I'm more happy with that answer than 5 factorial times 5. Well, it's the same thing as saying then times by 6 choose 1, which is what I was going to say. I think they give you the same answer. And then I would divide it by the total probability. All right. I'm pretty sure they're the same answer. 5 factorial times 5 times 6 choose 1. It should be the same as 3,600. 5 choose 1 times 6 factorial. Yep, that's my logic. 3,600 over, of course, the probability of the events all occurring. The probability of the events occurring would be what? Me just doing 10 choose 5. So any 10, just choosing 5. Sorry, choosing 6. Choosing 6. Do we agree? Which doesn't work because 10 choose 6 is only turning 10. Whoa. What am I doing wrong? What did I just do very, very wrong? Let me think. Am I wrong here? 0, 0, 0, 0, 0. Odd, 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 odd. Always worry that at least two of the numbers Kelsey chose are even. I still think this is the fastest way. 1 minus the 1 even. 1 even would be 5 odds and 1 even. To get 1 even, you've got a 6 chance of doing that. Sorry, you've got 5 chances of doing that. Times these ones here. Once you select an odd, there'll be less odd. So 5 factorial times 6. What is the total combinations? I've got 10 numbers. I'm just choosing 6 of them. 10, choose 6. Just do 10. 10, choose 6. It's only 210. What am I doing wrong? You're not going to divide it out. Unless, because order doesn't matter, it's just going to be fine. I can't say that. Let me see. The only other way I could think of it is if this is 10, choose 5. No, that won't work either, would it? 10, choose 5. 5, choose 5. 5 odd, you're choosing 5 odd. Times 5, choose 1. I don't know. Let's have a look. Do I even have answers to these ones? I don't think so. Alright, let's stop this.